Hey, this is Elizabeth, and today I'll walk you through how you can instrument your MCP server tool agent system using OpenTelemetry to perform distributed tracing and send the collected traces to any observability backend of your choice. For the context of the video, we'll be using Signal. So before the code walkthrough, let me show you the basic architecture of the MCP system in context. So this is just so that you can get an idea on how you can also instrument your MCP systems to perform distributed tracing. So this is basically a demo system and a demo architecture. So first we have a chat agent which is powered by Claude. Let's call it a Claude agent also, which makes LLM calls. This also makes calls to the MCP server, which has two tools that we will deal with. The first one is a calculator tool. So the calculator tool is for performing basic arithmetic operation and does not make any API calls. The next tool is the fetch tool. The fetch tool actually makes API calls to whichever website or whichever site is in question or in the prompt that we ask. So before we get into the code walkthrough, and before I show you how you can actually instrument your systems, I will show you the MCP system working as well as the end result of the tutorial, that is the distributed tracing and how it is visualized in Cygnus. So now let's see our MCP server in action. So I'm going to start the server. Let's do MCP npm run start. Okay. So this should connect the agent with all the MCP tools available. So my first prompt will be to perform a very basic calculator operation, or like say arithmetic operation. Let's do add 2 and 30. So this makes the agent calls the appropriate tool and then fetches me the result. So this looks good. The sum of 2 and 30 is 32. Okay, our second prompt will be to the fetch tool. So that is, I am going to try something like, can you fetch me the top 5 news from HN? So now the agent makes calls to the fetch tool, which in turn hits the HN API or Hacker News API and then fetches me the result. Okay, this should take a while, but yep. Okay, we've gotten the top 5 news from Hacker News also. So this is the MCP system in action. Now I'll also show you the entire trace journey and how this flow of actions look like in Cygnus and how it is visualized, which would also be the end result of our video. Let's get into that. So this is how the trace journey looks like in Cygnus and how it is visualized by Cygnus. We can see the entire trace journey with all the incorporating spans and the name of the spans here, the duration taken by each span or each call associated with this as well. So let's say if I select this span, I can see all the attributes associated with it, like say the service name, the content length, the fetch URL also, we can see this one. So almost all detail that we wanted to collect from every operation associated in this flow of actions is collected. We can see the similar trace journey for a calculator operation as well. Now let's get into how we've coded this. Although the entire thing looks pretty complicated right now, it's not. It's very straightforward and easy approach. It's very similar to how you would trace journey for a normal piece of software or normal functionality. It would hardly be around 30 to 35 lines of code. Let's get into it. Okay, now let's begin coding our tracing file. So the first step is to have a OTLP exporter. So I'm just going to roughly comment down all the steps that we have to cover, followed by a span processor, and then we have to configure our SDK, start our SDK, and then finally return the tracer. So Claude is already done by job. So let's just leave it like this. I would also like to specify that the OTLP endpoint that I'd be using will be the port 4318, which is for HTTP. I also have the OpenTelemetry collector running in a Docker container here and exposing two ports, 4317 for gRPC, 18 for HTTP. So I'll be using HTTP port for this video. So let's begin by specifying our port. Okay, cool. The next step is to initialize tracing by means of a function. So let's get into it. Initialize tracing, yes. And I'm going to put all these steps inside the function, and the final step of the function would be to return a tracer, which I'll then use it in the remaining files to instrument them. Okay, now let's specify our exporter. Cool. So this is exactly how I want it. I'm going to import the missing imports. Okay, works. The span processor, I'll be using a batch span processor. Let me import that as well. Cool. The next step is to configure the SDK. I'll need node name, a service name in that, span processors, takes in list, and I'll be passing my span processor as well. Auto detect resources set to false is correct. Instrumentations is also correct. I have to import both of them. Okay, cool. The next step is to start my SDK. I would like to put this in a in a try catch setup. Okay, I would also like to have a console statement here, tracing initialized. Cool. The next step is to, before I return the tracer, I have to get my tracer. Okay, this is exactly what I wanted, and I have to import trace from OpenTelemetry API. Cool, everything is done. So this should be it. I've covered all the steps here, and the next part of the video is to use the tracer that is being returned by this function in different areas of code so that I can set up spans, set up attributes and events, and have so much granular control over it and get the final output that was shown before. So next step will be to instrument the connect function in our agent file. So the connect function's functionality is to connect the agent to all the tools available. So let's do that next. So now let's start instrumenting our agent file. So there are two steps. First step is to get the tracer or define a tracer for our file by getting the tracer that we returned previously from our tracing file, this one. And the second step is to instrument our connect function to send traces to Signos. So let's first start with defining a tracer for this file. Okay, this looks good. Now we'll have to import initialize tracing from our tracing file. Okay, declares is not exported. Okay, I think we did not export this function previously. Let's export this function as well. So that is resolved. Let's get back to tracing our connect function. So there are two options. You can either use start span or start active span, but for this video, start active span is a better fit. I will walk you through why start active span is a better fit later. Let's start using start active span. So it would be return agent tracer start active span is right. We will pass a couple of attributes as well. This looks good. And then context.active and a callback function to the active span, which will be this entire function. So we are wrapping the entire function in this call. Okay. It is also important to note that if here we are wrapping a try catch file with this start active span, right? So try catch block. So we can also add a finally statement as well. And here I will set it to OK and I'll end my span as well. All of this has to be exported from the OpenTelemetry API. So let's first do that. Let's just add it here. Okay, that looks good. We've gotten all our imports ready and done is also done. Let's see if we want to change any of these attributes. Agent name, okay. Event connection operation, connect. Let's just do connect.mcp service. We are setting the status, span status to okay here, and on error, let's set it to, before we throw the error, let's set it to error as well. If needed, we can maybe add some details from this function itself to our trace. Let's see what is a good data to add. Let's look at, okay. Let's return the clients. Here we can also add a span statement. Cool. Clients connected dot size is a good data. Okay. So now that this is done, we can run our first test to see if the entire pipeline is working. Okay, now that we've done the basic instrumentation, we must be able to get traces for the connect event. That is, every time a connect happens, we must be getting traces to Signos. So let's just build this again. Let's also give a small prompt, but this should be enough to send a trace, but let's just give it a prompt as well. Cool. So now let's move to Signos and then see if we've had any. Our service name is Cloud Agent. Yeah, it's Cloud Agent. So we can check for that service. Let's just run this again. Okay, so we've gotten one trace which is from the Cloud Agent service. Okay, let's verify if it is the correct trace. So, and how do we do that? Let's look at the, so event is connection, operation is connect.mcp service, which is exactly what we had described before also, if I'm right. Like we've described, agent name is Cloud Agent, event connection, and operation is connect.mcp service. We also have the span name as agent connect, which is also similar to what we defined here. So our first step is done. We've instrumented the connect function, but this was also the most basic part of it. The distributed tracing is not yet visualized. We've not reached there. To get distributed tracing into action, we'll have to instrument a few more functions in this file, and then we'll have to instrument our tools also. So let's see where we start from. The entry point of the agent is the chat function, and then the chat function propagates to handle tool use function, which is defined above, and then it calls the appropriate tool. So we will be instrumenting our traces also in the same order. First, we'll start with instrumenting the chat function, then we'll move on to instrumenting the continuous looping function of the chat, and then we'll go on to instrumenting the tool, which is in our server folder. So the loop functions like this, like initially I had a add 2 plus 3 prompt. Next I can have a fetch top 3 news from say NY Times. So this calls the fetch tool, right? So this looping which happens, which again asks me for the next prompt. So this looping should also be instrumented. So all this will come under a single trace journey, which will be our final output, and which is what we will be doing next. Function. The very same procedure is what we are going to follow. We are going to return a span with agent tracer. Okay, so a start active span function takes in 4 arguments. We can see what it is. The first one is a name, which is agent chat, then any options, which are the attributes or events that we want associated with, so that will be passed. The next is the context. So here and previously we use context.active. The last is the callback function, that in which if there's any child span, all of it will be generated. So let's accept this. We have to add a finally block here. Okay, this looks good. Okay, so we also have one more level of instrumentation that we have to add here, which I had shown you before the prompt keeps happening. We have to instrument that also. So we'll be using the next span here, that is, let's do a await agent tracer dot. Okay, so the first one was chat. Okay, agent chat. Let's do agent dot turn, and here let's do await agent dot turn dot step. Cool. We have cloud agent, event is chat, operation is okay. All this looks good, but there's a small s here, so I'll get back to this later. So first thing is, when we are passing context for the next loop, it should have the context of the parent. That is, we cannot use context.active. It should have the parent spans context, right? So for that, there's a small hack which I'll be doing here. I am going to extract the parent span context. Okay, this is almost right. Let's just modify this context, which takes the current active context and takes the span, which is, in this case, it is the chat span, and creates a new context. Trace has to be imported. Let's import trace from OpenTelemetry API. Okay, so that part of it is done. Let's get to instrumenting the prompt loop. Okay, let's do await agent tracer dot. Very good, this is exactly what I wanted. Let's name this prompt span, and let's get to the end of this loop. Okay, I cannot find the end of this loop. Let's try the end of this try. Okay, cool. Let's add our finally block here. Cool, so this looks good. Let's add little more attributes to our prompt span so that it conveys way more details than what it is right now. What kind of details do we want to pass into our span? I see tokens here. We are dealing with tokens here. So let's add, okay, input tokens, cool, output tokens, cool. This would make it way more verbose than what it is right now. Let's also the length of the message. No, let's do prompt. Let's do message size, cool. So that is very contextual right now. I would also love to pass the turn count for both. The turn count is the number of turns it takes while it is doing a chat cycle. I would like to pass the turn count here as well. Here the turn count would initially be starting from 0. And let's increment it by 1 here. We'll have to increment it by 1. The turn count inside the function is also being incremented by 1. So this is the instrumentation of chat. We have to instrument our tool calling function, which in here is the handle tool use function. Let me show you where exactly this becomes called. The result of the tool inside our chat function is being handled by the handle tool use function. So let's go and instrument this function, which is a third layer of instrumentation. Cool. We use the same. So once you learn to trace, we are just applying the same logic and the same technique everywhere. Cool. So this has been instrumented. Okay, catch. let's do finally. Looks good. Couple of things I wanted to change. We can have the name of the tool here, right? So let's add the name of the tool, agent tool use dot tool name. So it becomes way more detailed, and looking at this one I'll be able to say if it is a fetch tool or if it is the calculator tool. I would also like to have it as a argument here. I would like to have the name as an argument. I don't want the tool arguments there. This is very detailed according to me. I want to add the span status. Okay, it is done. I want to add the span status as error here. Okay, let's run it and see how it looks like. And we also have to add one more level of instrumentation which is inside the tool, which we'll be doing in the next step. Okay, now let's see the result of our instrumentation. Let's open our terminal and see how this looks like. Make sure to do a build also before. I just built it previously, but okay. First, let's try the calculator function and add 2 and 40. This should be enough to send a bunch of traces to our backend. Okay, now let's see if we've gotten any trace. Let's filter it down to 5 minutes. Okay, so we've gotten a trace from Cloud Agent. Okay, this is a connect trace only. Okay, we've gotten a few more traces. It took a while though. Okay, so let's look at this post call. Right now we are able to see every single span being a part of this trace journey. So the turn step, which was our starting point, and then turn step inside our prompt loop, and then to our tool handle tool use function also being reflected here. Let's see if all our attributes have been caught. Everything has been caught here. Tool name is calculate. Let's also look at the turn step function and see the tokens are being reflected, the message size, input tokens, event, everything is being instrumented and recorded as expected. So the next part of it is to propagate the trace in the context to our tools as well. We have two tools, calculator tool and fetch tool. So we have to propagate the same context to our tools, which is very similar to what we've done before, so that we get one more deeper level of observability. So let's look how that is done. So now we are getting to the last leg of our video. So here we will have to propagate the context from our Cloud Agent and from our handle tool use function to the corresponding tool that is being invoked. So we have two tools inside the servers folder, calculator tool and fetch tool. Challenge here is to propagate context from the tool use function to this tool. So this is the essence and concept of distributed tracing, wherein we propagate context across distributed services, across different folders, across different functions, etc. If you're familiar with Kafka, you might be aware that method used to achieve this is by passing trace context as a Kafka head. So here we are doing something very similar, which is this is the function which invokes the server tool. So here we'll be passing the trace context also, but as meta. And then trace context. Okay, I also want to add one more attribute to this object, which is true, is remote true. So right now this can be accessed by my tool here. Let's see how calculator is instrumented. So currently I have a server tool block, and then I have a function for handling the calculation, which is basically the calculator logic. Here I'm going to extract the context that was passed, parent. Okay, I'm extracting it from trace context, which is cool. The next step is so now I've gotten the span context from the meta, but right now it's just an object, or like let's say some data. It's not a span object which could be identified by any of trace related functions which we'll be using later. So let's make it a context object, right? Okay, first step would be to, let's say, create a context object with it. Let's do this, and I have to also import OpenTelemetry from OpenTelemetry. Gotten this. So if you look at it, you can see what wrap span context does here. It wraps the given span context in a new non-recording span, which is our parent span, and turns the non-recording span with the context that was provided. Now let's create a new context with this span and the current active context. This works. I have to add context also. Cool. So you can also add a conditional statement which checks and directly calls the handle calculation function in case there is no context that is passed. But I'm not adding the check here. Let's directly get to how this works. Let's do return. Okay, get my tracer here from the tracing file. Let's do const tool tracer. Oh, that looks good. Then me import it also. So now I'm going to return tool tracer, start an active span, the name of the span, attributes, context, span, looking good. So this should be it. Let me import span also. What else is left? I would love to put this in a try catch loop as well. Sorry, try catch block or handle. Okay, everything is done. This is missing import. That is done. Cool. Are we setting the status? Yes, we are ending the span also. I would love to change the name of the span here to tool span. This is just for readability and does not have a lot of meaning other than making the code more verbose. Okay, so I've instrumented my tool as well. Now let's build it, run it, and see how the traces look finally. So just like we instrumented our calculator file, where we applied the same logic to a fetch file as well for the fetch tool also, and I've already added the so we are extracting the same context, creating a context object, and then using that context to create another active span here. So let's see this in action and see if the trace journey is being replicated as we showed initially in our video. So make sure to build this before you start. I've already built it, so let's just start the server. Cool. So my first prompt will be to, let's say, multiply two numbers. We should be able to see the trace journey right now in Signals, but let's also do one prompt for the fetch tool as well. Sorry. We'll do top 5 from Hacker News again. Now that we've gotten the result from our fetch tool also, the next task is to go to our Signals site and see if everything has been collected and if we've been able to create a trace journey. Let's filter it down to 5 minutes. Okay, we have a bunch of traces here. Let's start with this. So this should probably be for the fetch tool. Okay, so we have all our traces starting from turn, then going to turn step, tool fetch, and inside this we should have our fetch tool use. Okay, so we are seeing our entire trace journey here with all the durations, with all the spans, all operations, and all calls being made. Okay, this should be for the calculator. So this is how the traces look like for our calculator tool. Being able to see the operator and the operand, the operation, everything is very verbose and detailed. So we've successfully completed instrumenting our MCP system to send very detailed distributed tracing to Signals, and we visualized it here as well. I've also mentioned that I'd tell the difference between start span and start active span while we were coding. Start span is just for creating a span without the idea of parent span, child span, etc. But then when you're working in a way more complicated and in a distributed tracing kind of setup, it's always prefer to use active span because this would create a parent span and all the other spans which are created as a part of the function which is passed as a callback to the active span function will be treated as its child spans, as we can see here as well. So we finally come to the end of our video and hope you actually understood how you can instrument your MCP system to perform distributed tracing and send actual meaningful tracing data. A potential next thing that you can try is to instrument your MCP system to send metrics as well to your observability backend. All the links that I had mentioned in the video of the blog as well as the entire code of instrumented MCP system will also be attached in the description box below. Hope you had a very nice time listening to me. Thank you.